Welcome to the Education and Labor Cabinet's Work Zone Safety webinar. In this training video, we will discuss the importance of having a properly set up work zone and how to ensure proper safety techniques are being utilized. Please take a moment to read this disclaimer. Feel free to pause the video here. The objectives of this course are to learn what a work zone is and how to identify one, to learn which regulating authorities provide standards and practices for work zone activities, as well as identifying some of the applicable standards, to learn some of the hazards associated with work zone activities and some recent statistics on work zone related incidents, to learn some of the basic operations of a temporary traffic control plan and how a work zone is set up, and to learn some of the operations around flagging, such as when it is used and what qualifications are required. So what is a work zone? A work zone is defined as a temporary work site for maintenance of highways, road, and streets. Often work zones use cones, barrels, or barriers to guide traffic outside of the work site, such as what you would see in a work zone on a major highway, but this is not always the case. Operations such as mowing, pothole repair, pavement striping, and snow plowing can use methods such as warning signs, shadow vehicles, and flashing lights. The regulating authorities for work zones include the Occupational Safety and Health Administration and the Federal Highway Administration. The Federal Highway Administration created the Manual on Uniform Traffic Control Devices, MUTCD, which contains the national standards governing all traffic control devices. Additional standards such as Kentucky Administrative Regulations and the Kentucky Revised Statutes are specific to Kentucky. Other standards incorporated by reference by OSHA include the American National Standards Institute, National Fire Protection Agency, and the International Association of Fire Chiefs. The Federal Highway Association's Manual on Uniform Traffic Control Devices is the main source for work zone regulations. The map above shows what states have adopted the national MUTCD, what states have adopted the national MUTC along with additional state regulations, and what states have adopted their own MUTCD. Kentucky has adopted the national MUTCD, meaning all work zones within the state must follow the most current edition of the MUTCD. Within the MUTCD, it is important to understand the format of the text. If the text is a standard and mentions the word shall and is in bolded text, that section of the manual is a standard and is mandatory by law. If it uses the word should and is italicized, then it is not required by law, but is strongly recommended. If the word may is used in regular text, then that section of the manual is providing information of an optional alternative. Lastly, everything listed in regular text not using the word may is all additional information or supporting text. The Occupational Safety and Health Administration covers very little on work zones. The MUTCD is referenced by OSHA in 29 CFR 1926 Subpart G, signs, signals, and barricades. It is also incorporated by reference within 29 CFR 1926.6. The standards in this subpart cover the general requirements for accident prevention signs and tags, and the general requirements for flaggers or signal personnel. OSHA standards are not very specific on work zone requirements. Therefore, the MUTCD should be the primary resource used when determining regulations. Other than the MUTCD and OSHA, there are Kentucky Revised Statutes and Kentucky Administrative Regulations, which are two bodies of state laws. Included in these are some regulations that influence work zones, such as double fine areas, right-of-way to emergency vehicles and workers in a work zone, and others that help enforce driving cautiously through work zone areas. Further information on these regulations can be accessed online through the state's database. In 2021, there were 164 pedestrian fatalities occurring in work zones, 323 commercial motor vehicles involved in crash fatalities, 956 total work zone fatalities, 42,000 work zone injuries, and 106,000 total work zone crashes. Some of the most common hazards workers can be exposed to during work zone operations include falls, electrical, struck by, and caught between. Struck by moving objects and falls account for the two highest causes of injuries in work zones. Falls result in the most non-fatal injuries, while struck by incidents result in the most fatal injuries. Workers such as emergency responders, cleanup, utility, demolition, construction, and others in areas where there are moving vehicles and traffic are exposed to being struck by moving vehicles. Again, struck by incidents account for the highest number of work zone fatalities. Moving construction equipment backing into workers, the public driving personal cars into someone, and falling objects are some of the most common struck by incidents. Common causes include confusing work zones, low visibility and poor weather conditions, lack of necessary signage, lack of warning time, and lack of proper training. Proper training is the most important topic to prevent work zone related incidents. Before work zone activities begin, these questions should be considered. Have you notified emergency service providers and public safety agencies? Have you determined how it will affect day-to-day activities? Have you determined how it will affect any civil events? Have you determined how it will affect school activities? Has public information been sent out regarding the upcoming road work? Have you reviewed crash history in the area? And lastly, have you surveyed the area to determine a best plan of action? After conducting the pre-plan activities, a temporary traffic control plan should be developed. A temporary traffic control plan is a document that details the placement of temporary traffic control devices on a street. These devices include signs, cones, barricades, temporary barriers, crash cushions, traffic drums, flashing arrow signs, electronic message signs, and more. The plan describes temporary traffic control measures to be used for facilitating drivers through a work zone or an incident area. These should be specific to each work zone and follow the guidelines given by the MUTCD for traffic control setup. All pre-planned and temporary traffic control activities should be conducted by individuals who are knowledgeable, for example, trained and/or certified in the principles of proper temporary traffic control. After pre-plan activities and a temporary traffic control plan have been completed, you are ready to begin the setup of a temporary traffic control zone. In section 6C.03 of the MUTCD, it defines the four basic areas of a temporary traffic control zone. Figure 6B1 in the manual breaks down these four zones. Most temporary traffic control zones are divided into these four basic areas: the advance warning area, the transition area, the activity area, and the termination area. Section 6B.04 of the MUTCD defines the advance warning area as a section of highway where road users are informed about the upcoming transition and activity areas or incident area. The advance warning area may vary from a single sign or high-intensity rotating, flashing, oscillating, or strobe lights on a vehicle to a series of signs in advance of the temporary traffic control zone activity area. Typically, an advance warning zone is a 3-sign series. The table above is Table 6B1 from the MUTCD, showing the recommended minimum spacing between advance warning signs. The column headings A, B, and C are the distances between advance warning signs. The A dimension is the distance from the transition to the first sign, the B dimension is the distance between the first and second sign, and the C dimension is the distance between the second and third sign. On urban streets, the effective placement of the first warning sign in feet should range from 4 to 8 times the speed limit in miles per hour, with the high end of the range being used when speeds are relatively high. When a single advance warning sign is used in cases such as low-speed residential streets, the advance warning area can be as short as 100 feet. When 2 or more advance warning signs are used on higher speed streets, such as major arterials, the advance warning area should extend a greater distance. Since rural highways are normally characterized by higher speeds, the effective placement of the warning sign in feet should be substantially longer, from 8 to 12 times the speed limit in miles per hour. Since 2 or more advanced warning signs are normally used for these conditions, the advanced warning area should extend 1,500 feet or more for open highway conditions. Typical distances for placement of advanced warning signs on freeways and expressways should be longer because drivers are conditioned to uninterrupted flow. Therefore, the advanced warning sign placement should extend on these facilities as far as 1/2 mile or more. Section 6B.05 of the MUTCD defines the transition area as the section of highway where road users are redirected out of their normal path. Transition areas usually involve strategic use of tapers, which, because of their importance, are discussed separately in detail. The standard for transition areas in this section of the MUTCD states that, except for mobile operations, when redirection of the road user's normal path is required, road users shall be directed from the normal path to a new path with appropriate channeling devices, traffic control devices, and/or TTC methods. Remember, if the text is bolded and uses the word shall, it is required by law. Section 6B.06 defines the activity area as the section of highway where the work activity takes place. It is comprised of the workspace, the traffic space, and the buffer space. The workspace is the portion of the highway closed to road users and set aside for workers, equipment, and material, and a shadow vehicle if one is used upstream. Workspaces are usually delineated for road users by channeling devices or to exclude vehicles and pedestrians by temporary barriers. The traffic space is the portion of the highway in which road users are routed through the activity area. The buffer space is the lateral and/or longitudinal area that separates road users' flow from the workspace or an unsafe area and might provide some recovery space for an errant vehicle. The last area of a temporary traffic control zone is the termination area. Section 6B.07 of the MUTCD defines the termination area as the section of highway where road users are returned to their normal driving path. The termination area extends from the downstream end of the work area to the last TTC device, such as an end road work sign or a speed limit sign, informing road users that the speed limit has returned back to the typical speed of the roadway. Typically, a longitudinal buffer space is used between the workspace and the beginning of the downstream space to return traffic back to regular flow. Section 6B.08 of the MUTCD goes into detail on using tapers and the requirements. A taper is the area of a work zone where road users must adjust their path of travel. Tapers may be used in both the transition and the termination area. They are created by using a series of channeling devices and/or pavement markings to move traffic out of or into the normal path. The length of the taper changes depending on the type of taper being used, the width of the transition area, and the posted speed limit. Figure 6B2 in the MUTCD shows the different types of tapers. A merging taper requires the longest distance because drivers are required to merge into common road space. A merging taper should be long enough to enable merging drivers to have adequate advance warning and sufficient length to adjust their speeds and merge into an adjacent lane before the downstream end of the transition. An example of a merging taper is when road work requires a 2-lane road to go to a 1-lane road, like what is shown in the figure. A shifting taper is used when a lateral shift is needed. When more space is available, a longer than minimum taper distance can be beneficial. Changes in alignment can also be accomplished by using horizontal curves designed for normal highway speeds. This figure from the MUTCD shows a 2-lane shifting taper that reroutes traffic around the work zone. A shoulder taper might be beneficial on a high-speed roadway where shoulders are part of the activity area and are closed, or when shoulders might be mistaken as a driving lane. In these instances, the same type but abbreviated closure procedures used on a normal portion of the roadway can be used. However, if the shoulder is being used as a travel lane, either through practice or during temporary traffic control activities, a normal merging or shifting taper should be used instead. The example in the figure from the MUTCD shows a shoulder taper being used in a two-lane road to block off the work zone area. A downstream taper might be useful in termination areas to provide a visual cue to drivers that access is available back into the original lane or path that was closed. This type of taper is optional. The example in the figure from the MUTCD shows a downstream taper being used in the termination area of a two-lane road. Figure 6B3 from the MUTCD shows a one-lane, two-way traffic taper. The one-lane, two-way taper is used in advance of an activity area that occupies part of the two-way roadway in such a manner that only one lane of the road is accessible to road users. This type of taper requires flaggers on both sides of the taper. The requirements for flagging will be talked about in a later slide due to the importance of this operation. In order to calculate taper length, Tables 6B3 and 6B4 from the MUTCD should be used. Using the formulas from Table 6B4, where W is the width of the offset of the taper in feet, and S is the posted speed limit, you can calculate L, or the length in feet of your taper. For speed limits 40 miles per hour or less, multiply the width of the offset by the speed limit squared and divide that by 60 in order to get the necessary length in feet of the taper. For speed limits 45 miles per hour or greater, multiply the width of the offset by the posted speed limit in order to get the necessary length in feet of the taper. For merging tapers, they must be at least the length calculated using the necessary formula. For shifting tapers, they must be at least half the length calculated by using the necessary formula. For shoulder tapers, they must be at least a third of the length calculated by using the necessary formula. Lastly, both downstream tapers and one-lane, two-way traffic tapers should be a minimum of 50 feet and a maximum of 100 feet long. The following example shows how to calculate taper length at speeds 45 miles per hour or greater. Using the formula L equals W times S, where W, or the width of the lane, is 12 feet, and S, or the speed limit, is 65 miles per hour, you can solve for L, which is the length of the taper. Multiply the width, 12 feet, by the speed limit, 65 miles per hour, which gives you a taper length of 780 feet. For a merging taper, the length must be at least L, which is 780 feet. For a shifting taper, the length must be at least 0.5 or half of L, which is 390 feet. And for a shoulder taper, the length must be at least 0.33 or a third of L, which is 257.4 feet. Note that if you are calculating the length of a shoulder taper, then W, or the width, will be the width in feet of the shoulder rather than the lane. This example shows how to calculate taper length at speed limits 40 miles per hour or less. Using the formula L equals W times S squared divided by 60, where W, or the width of the lane, is 12 feet, and S, or the speed limit, is 35 miles per hour, you can solve for L, which is the length of the taper. First, using order of operations, you will square 35 miles per hour, which gives you 1,225 miles per hour. Next, multiply 12 by 1,225 to get 14,700 and divide that by 60, which gives you a taper length of 245 feet. Again, for a merging taper, the length must be at least L, which is 245 feet. For a shifting taper, the length must be at least 0.5 or half of L, which is 122.5 feet. And for a shoulder taper, the length must be at least 0.33 or a third of L, which is 80.85 feet. Flagging is a work zone operation that requires the use of a flagger to direct traffic. A flagger is the safety professional that controls the flow of traffic. Most commonly, this is needed in one-lane, two-way roadwork activities or emergencies. When there is only one lane accessible to two-way traffic, a flagger should be used at both ends of the zone to coordinate traffic flow. The flagger should always use a stop-slow paddle unless one is not available in the event of an emergency where a flagger is needed. The MUTCD states that the stop-slow paddle shall have an octagonal shape on a rigid handle, and if used at night, shall be retroreflective. OSHA mentions flagging operations in 26 CFR 1926.201A, which states signaling by flaggers and the use of flaggers, including warning garments worn by flaggers, shall conform to Part 6 of the MUTCD. Section 60.01 of the MUTCD provides the necessary qualifications for flaggers. Because flaggers are responsible for public safety and make the greatest number of contacts with the public of all highway workers, they should be trained in proper traffic control practices and public contact techniques. Flaggers should be able to demonstrate the following abilities: the ability to receive and communicate specific instructions clearly, firmly, and courteously, the ability to move and maneuver quickly in order to avoid danger from errant vehicles, the ability to control signaling devices such as paddles and flags in order to provide clear and positive guidance to drivers approaching a TTC zone in frequently changing situations, the ability to understand and apply proper traffic control practices, sometimes in stressful or emergency situations, and the ability to recognize dangerous traffic situations and warn workers in sufficient time to avoid injury. It is important to remember that the employer is responsible for ensuring that any employee conducting flagging activities is trained. Flaggers should be used anytime road work on a two-way road only allows for one lane to be accessible, unless there is low traffic volume or temporary traffic control signals are in place. Figure 6P10 from the MUTCD shows the typical setup for a lane closure on a two-lane road using flaggers. Signs should be used in order to warn road users of the upcoming work. For signs A, B, and C in this scenario, sign C typically warns traffic of how many feet until the road work. Sign B shows how many feet until the road turns into a one lane. And sign A shows how many feet until there is a flagger. Remember, sign A is the closest to the flagger, and sign C is the furthest. A flagger should be used on both sides of the work area during a lane closure on a two-way road. They should be easily visible to oncoming traffic, and if possible, the side of the road or shoulder is the safest place for a flagger to stand so that they are not in the path of oncoming traffic. All workers, including emergency responders within the right-of-way who are within the TTC zone, shall wear high visibility safety apparel that meets the Performance Class 2 or 3 requirements of the ANSI 107 2015 publication entitled American National Standard for High Visibility Safety Apparel and Headwear, or equivalent revisions. Class 3 is recommended for nighttime activities since it is the most reflective. Any firm, individual, or governmental agency that wants access to a road on the Kentucky State Highway System or wants to conduct any type of work activity on the right-of-way must obtain a permit from the Kentucky Transportation Cabinet. The policy and procedures for the following permits can be found in the Kentucky Transportation Cabinet Permits Manual: utility facility installations, permitting of entrances and other correlated roadway modifications, altering or replacing existing drainage facilities, plantings upon the right-of-way, replacement of right-of-way fence, tree trimming and cutting, use of roadside chemicals, airspace usage, geophysical surveys or investigations, treated sewage, locating facilities on the right-of-way, fairs, parades, festivals, banners, and welcome signs, school site agreements, recycler permits, and tourism signs. For any permit-related question, contact the Kentucky Transportation Cabinet at 502-564-4890. For more information on work zones, scan the QR code to access the 11th edition of the MUTCD. This concludes the Work Zone Safety webinar. Thank you for attending. For more free online learning opportunities, please visit our website at kysafe.ky.gov.